Hello my dear students, this is Akash SD. Welcome to the SD Physics classes. Hope you all are doing really great. So students, in this video we are going to learn the Kirchhoff's laws. Under that we are going to see the two laws. One is the KCL, one is KVL. After that we will solve some questions also. So students, let's start the video and let's learn all these things. So you can see students when to use the Kirchhoff's law. So see here, there are two Kirchhoff's law to calculate current and potential difference in a complicated network. Now the question arises, complicated network means, that means in a network, that means circuit where series combination of resistors, parallel combination of the resistors, we can't identify it. This is all mixed up. So in this situation we left with only this choice, that means KCL or KVL. Even this concept is applicable in case of capacitors also. Not only resistors, in case of capacitors also we can use it. Okay, so let's learn the basic. The first one is, you can see the first law, junction law or a KCL. So see here, what is this? The algebraic sum of the currents meeting at a junction in an electric circuit is always zero. Algebraic sum, why we are telling? Because current is the scalar quantity, not a vector quantity, but still it can be negative. Okay, this law can also be written as here, the sum of the currents entering a junction in an electric circuit is equal to the sum of the current leaving that junction. Okay students, so this rule you have to remember that, just mug up it because it will come in exam, especially CBSE exam definition. If we see here the mathematically, let's take for example here, so many branches are there, they are meeting at this point. Okay, so this is called here what? This is called here the junction. Okay, so mathematically what will happen that here, this summation of I will be equal to 0 at any junction. Okay, and if in case students, if I take here, let's take for example here R1, current is coming I1, let's take this is R2, here current is coming I2. For example, let's take R3, current is coming I3, and let's take this is the R4, current is going away I4, this is R5, and again current is going away I5, just for the example. So what will happen that here students, remember that here I will take incoming current positive, then outgoing current negative, reverse also you can take, not a problem. Okay, so what will be here? Incoming current means I1 plus I2 plus I3. Outgoing current, what I told, negative, that means minus I4 minus I5 equal to 0 according to this. So we can write here, see, I1 plus I2 plus I3 is equal to I4 plus I5. Now that means the second statement of the KCL, the sum of the currents entering a junction is equal to sum of the current leaving the junction. And remember that here KCL is based on the conservation of charge. How can we tell this? Because you know very well, the current means the rate of flow of charge. That means the rate of flow of charge entering the junction is equal to rate of flow of charge leaving the junction. There is no accumulation of charge at the junction. That means we can tell that KCL is based upon conservation of charge. Is it? So kindly see very well how we have done this. Okay, great. Now students, after that if we see the second law, loop law or a KVL means Kirchhoff's voltage law. See here, the algebraic sum of the voltage drops across resistors and cells in a closed circuit is always 0. Now sum of the potential drops across these elements will be 0. So we can write here what is sigma V equal to 0 summation. Okay, and if we will just simplify this furthermore, so this V can be dropped across the cells or maybe dropped across the resistance also. Okay, it can be plus IR, it can be minus IR depending upon the direction of the current, that we will see it. Okay, so students, this thing you have to remember that here, this is the Kirchhoff's voltage law. Okay, and to apply the Kirchhoff's rule, especially the voltage rule, you should know the basic rules. So what is the basic rules here? For the cell C, while moving from negative to positive terminal inside a cell, EMF is taken as a positive and vice versa. That means students, if I will just take here for the example, so see here students, if in case the cell is like this, no? Long line plus, short line minus. So if in case what is happening that here students, we are moving from where to where? Negative to positive. Okay, so first let me tell you this one here. This is negative, this is positive. Now, okay, so students, what will happen that here, when you are taking negative to positive, then we have to take which sign? Plus sign. When you are going negative to positive, you will take the plus sign. And students, vice versa means when you are going positive to negative sign, then you have to take here the minus sign. That means all the situations you have to take the second sign. Which sign, students, here? This sign, and that which sign we have to take here? This sign should be always we have to take here the second sign, okay? Positive to negative means negative, negative to positive means positive here, okay, students? So this thing you have to remember that here, long line plus, short line minus. After that, students, second one you can see very well here. While moving in the direction of current in circuit, the potential drop across a resistance is taken negative and vice versa. Then from here, what we can get here, see, let's take for example, this is the resistance here, okay? And let's take the current is going in this direction. So remember that here, this is plus, this is minus polarity we have to write here, okay? And here what will happen that here, see here, if in case you are moving in this direction, in the direction of the current, then you will take here which sign? You will take here the second sign, that means a minus sign. If in case, students, you are moving in a opposite direction, opposite direction. Let's take here, I have taken here this direction here. See, color is not coming. If in case you are moving in this direction here, where? In the opposite direction of the current, then you will take here the plus sign, okay? Remember that here. And one more thing, students, please remember that here, if in case the current is going like this, if the current is going this plus, this minus, okay? So if the current is going like this, this plus, this minus. If the current is going opposite direction, plus and minus, okay? And as I told you, when you are going in the direction of the current, second sign minus. If you are going in the opposite direction of the current, second sign, that means a plus. I hope so this is the very, very clear. So students, here I have taken here some circuit here, okay? So see here, students, in this circuit, we are going to write here the KVL equation, okay? So see, so you can see very well, let's take from the battery E1, cell E1, I1 current is coming. From cell E2, I2 current is coming, okay? And here, if we use here the KCL here how much with current will go? It will come here, students, here I1 plus I2, okay? So now this KCL is satisfied. Now we'll write here the polarity. See, the current is going this side, that means this plus, this minus, is it? And here the current is going this side, here you can see very well here I2, that means this plus, this minus. Here also the current is going in this direction, that means this plus, this minus, okay? Now students, if we write here the equation, so for equation means we have to write here the loops. I have taken the names A, B, C, D, E, F, okay, students? So what will happen that here, let's take for example, if I take here, how many loops are possible? If you will see here, the 3 loops are possible. First one, second one, overall third one, okay, students? So see here, if I take the loop, for example, A, B, E, F, A. What I have taken? A, B, E, F, A, okay? So in this situation, students, when we write here, we can start from anyhow, but let's take, I am writing like this here, and I am going to start with the battery in this direction. You know, this is minus, this is plus, this is plus, this is minus, as I have told you, okay? So what will happen that here, when you will go in this direction, I have started from the E2, okay? So second sign always, E2, second sign, then second sign minus, current is I2 R2, means potential drop across the resistance I2 R2. Again you move this here, it will become second sign minus E1, then we can write here C plus I1 R1, okay? Plus E2 minus I2 R2 minus E1 plus I1 R1, and again we reach to the same place, that means equal to 0, okay? Great. Now students, after that, if we take the one more loop is there, one more loop. Let's take here, I have taken the upper loop. Name of the loop, see here, B, C, D, B, C, D, E, B. B, C, D, E, B. So students, now let's take here, we are going in this direction. I am moving in this direction, and again I have started with the battery E1. So see here, second sign E1 plus, then minus, current how much here? I1 plus I2 into R, and again you move here, second sign, that means minus I1 R1 is equal to 0. We went like this, and we have taken which sign, students, here? Second sign, okay? If in case, students, will take care of the outer loop. All the time, no need to write all the equations. Depending upon the requirement of the question, we have to decide which loop to choose and how to write the equation, okay? Now we'll take the outer loop. So A, C, D, F, A, outer loop, okay, students? So now if I write here the outer loop here, remember that here, again I'm going to start with this battery, okay? So now I write here, see directly, E2, second sign, minus I2 R2, again we'll move like this here, minus I1 plus I2 into R, is it? And again we reach to the same place, that means equal to 0, only at 3 places drops are there, 1, 2, 3. And remember that, students, this KVL is based upon the conservation of energy. So I hope so you have understood very well, students, how to solve with this kind of a situation, is it? Now students, after that we'll go ahead. Okay, now so see the students here the question is this. See the question here, important for the NEET and JEE. See the question is, see, value of current in the following circuit is how much? This circuit is given, just apply the KCL. Is it? So see here, this 10 ampere is coming here. Okay, 6 ampere went this side, that means here how much is students here? 4 ampere. Is it? Now you think 4 ampere and here 1 ampere, here how much is students here? 5 ampere. Now you think 6 here, 2 here, here how much here? 8 ampere. Now 5 this side, 8 this side, that means total how much here students? You can write here this 5 plus 8, that means 8 plus 5, how much here? 13 ampere. Which option is correct here? The correct option is here option A. Can you see very well how we have done in a beautiful way? Is it? Great. Now students, after that if we'll go to this question here, see here the question. The potential difference VA minus VB between the points A and B in the given figure is how much? Okay, so remember that here the current is going this direction, this plus, this minus, this plus, this minus, battery anyhow, long line plus, short line minus. And remember that here the loop is, it is not a loop, it is just like a open circuit. Is it? So in this situation, or open circuit means, or we can tell that this is the part of the circuit, this branch is part of the some big circuit, and we have to calculate potential difference VA minus VB. Then you know what will we do here? We'll start with the first point. I have started with the VA. Take second sign, minus, current is 2, resistance is 2 IR, Ohm's law. Then again second sign, minus 3, then again second sign, minus, current is 2, resistance is 1, and we reach to point B, that means here VB. So students, when we will simplify this, it will come here, see, VA minus 4 minus 3 minus 2 is equal to VB. Okay, so see here, VA minus 4, 3, 2, 9 is equal to VB. So see here now, this VA minus VB, how much is students? See, VA minus VB is given here the 9 volt. Okay, that means which option is correct here? The correct option is here option B. Is it? So see how much beautiful way we are doing all these things. Now students, see this one here. See the question. Find out potential difference between points A and B, and this is the circuit. Now this is point A and this is the point B. So students, here you can see the two batteries are there. One is the 2 volt, one is the 5 volt. Polarities. You know very well 5 volt battery will send the current anti-clockwise, and this 2 volt battery will send the current clockwise. Which current will be strong due to 5 volt battery? Okay. So remember that here the current will flow in this direction anyhow. So let's take students, the current is flowing I. Here also how much current is going here students? I. Okay. So now we'll take here the polarities. Plus, minus, plus, minus. Here also see plus, minus, plus, minus. Is it? Now again we'll use here the KVL. Okay. So students, if we'll use here the KVL, start. Let's take I'm starting with the 5 volt battery. Second sign. 5 minus 1 into I. Again 1 into I. Second sign minus 2. Now minus second sign, minus 2 into I, minus 2I. Ohm's law we are using. Here also minus 2, current I. So minus 2I is equal to how much here? 0. So students, you can write here 5 and minus 2, how much here? 3. And see here, minus 2I, minus 4I, minus 5I, minus 6I. So 3 minus 6I is equal to 0. So when you will simplify this, it will come here 3 by 6. And how much it will come here? It will come here 1 by 2 ampere. Is it? But what we have to calculate? We have to calculate here the potential difference. Anyhow, you can move A to B in this way, or you can move A to B in this way. Anyhow, you will get the answer. Okay. But let's see, I am moving A to B in upper loop. So see, VA, second sign. So plus 1, resistance 1, current I. So plus 1 into I means I. Here you can see students, minus 5. Again second sign, plus 2 into I, that means plus 2I. And where we reached? We reached at point B. Is it? Instruments. So what will happen here? See, this VA, I value 1 by 2 means plus 0.5, minus 5. And here again what will come here? 2 into 1 by 2 means 1 is equal to VB. Is it? So we can write here, see, VA minus 5 plus 1 minus 4 plus 0.5 means minus 3.5 is equal to VB. So students, if I write here the VA minus VB, what will come here? You can see here 3.54. Now you can see from here. Which option is correct here? The correct option is here, options A. Kindly see very well. Is it? So how we are using the KVL in a beautiful way. Now students, in this question, if we talk about here, see the question is, see, in the following circuit, the magnitude of current I1 is how much? Okay. So here little bit some complicated circuit is this. But whenever any kind of circuit is there, what we have to do? We have to first satisfy the KCL, Kirchhoff's current law. So see, I3 is coming, I1 is coming. That means here how much will come here, students? See, I1 plus I3. Is it? After that, what will happen here, students? When the current will reach here, I2 went this side. That means here how much? See here, I1 plus I3 minus I2. Is it? Now, students, after that, after reaching is this, the current I1 will go this side because I1 is coming out. I1 have to enter. So if the I1 will go this side, here what will go here, students? Here, I3 minus I2. Is it? And here also what will happen at here? I3 minus I2 will come. I2 from this side and it will become I3. So I hope so now this KCL is valid. Now we have to use here the KVL, A, B, C, D, E, F to get the value of I1. Multiple equations we can write, but depending upon our intelligence, we have to think which loop to choose. So depending upon my intelligence, students, I am taking the loop. First outer loop I am going to take. It is what here? A, B, D, E, A. See here, A, B, D, E, A. Okay, students. So now what we'll do here? We'll write here the equation. Let's take, for example, A, B, D, E, A. I have chosen here. Okay. So you can start from anywhere, students, but okay. Let me write here the polarity, plus minus. Okay. And here what is this? Let me write the polarity, plus minus. Here also plus minus, current in this direction. Plus minus polarity, we have to mention plus minus. Okay. So now let's take, for example, if I am moving from here, from anywhere we can move. I am going to move like this. So what this will become here? See, minus 2I3. Now in this second sign, minus 2I3. And here what we can write here? See, second sign, minus 2, minus 2I3, minus 2. And here second sign, minus resistance 2, current how much here? I3 minus I2, and again we'll reach to the same place, that means 0. See very well, minus 2I3, minus 2, minus 2I3 minus I2 equal to 0. Okay, students. So when we'll simplify this here, see, minus 2I3, minus 2, minus 2I3, plus 2I2 is equal to 0. Okay, students. So now what will happen at here? 2I2, and here minus 2I3 means minus 4I3 minus 2 equal to 0. Okay. Now what will happen at here? If we'll just simplify this somewhat. So see here, 2I2 minus 4I3 is equal to 2. Okay, students. Now if we divide both the sides by 2, so I2 minus 2I3 is equal to 1. Is it? So this one we have got here equation 1. Okay. But what we have to calculate here? We have to calculate here the I1. Okay. So now what I will do here? I will just move in this loop. Can you guess, students, which loop I am talking about here? This loop here. By my intelligence, I thought here. So F, C, D, E, F. F, C, D, E, F. Okay. So let's take, I am moving in this direction. Let's take, I am moving in this direction. So see here, I will write here, see, plus second polarity, I1 plus I3. Resistance how much here? Resistance here, students. Here resistance is there. Na? Let's take here. This resistance is the, actually the 1 ohm is there. Is it? 1 ohm is there. Na? I think so. I just forget to write resistance. Okay, but see here. This is the 1. Okay. Now after that, what will happen at here? See here. Second sign, minus 2. Okay. So plus I1 plus I3 minus 2. And here again will come here, see, plus 1 into how much current here? I1 plus I3 minus I2. Okay, so see, I1 plus I3 minus I2 is equal to 0. Is it? Kindly see very well here. We are moving in this direction. Okay, second sign, plus I1 plus I3 into 1 minus 2, and here again plus I1 plus I3 minus 2 equal to 0. Okay, so students, when we'll simplify this, what this will become here? See, this will become here, see, I1 plus I3. I hope so this is 1. Okay. And what is this here, students? See, minus 2, and what this will come here, see, students, plus I1 plus I3 minus I2 equal to 0. Okay. Now students, after that we have to collect all these things. Okay. So students, we can see very well here, this I1, see here, this I1 and this I1, it will become here 2I1. Okay. I am just collecting with the I1, 2I1 here. Okay. And this I3 and I3, it will become here, students, how much here? 2I3. Okay. And after that, what is this? This minus I2 is left, minus I2. And minus 2 equal to 0, that means I can write here equal to 2. When you will simplify this, you will get it very well. Okay, students. Now you know very well, students, here, see here. You know very well here, see. if in case students, I will just simplify this somewhat. This one is this. I will simplify here. Okay. So let me just write here. See, this is 2I1. 2I1. Is it? What is the value of 2I3 minus I2? If you see from here, 2I3 minus I2. 2I3 minus I2. See, if I put the minus sign, for example, then you can write here. See, I2 minus 2I3 is equal to 2. Is it? Just simplification. Now see here. 2I1 minus I2 minus 2I3, how much here? See now very well. Magic. Minus 1 is equal to 2. Then you can write here, see, this 2I1 is equal to 2 plus 1, 3. Is it? So now students, when I will write here the value of I1, what this will come here? See, 3 by 2. That means how much here, students, here? 1.5 ampere. Here, how much to fill here? 1.5 ampere. Kindly see very well, students, here. Is it? So what we have done? First we have used here this outer loop, and which equation we have got? We have got I2 minus 2I3 equal to 1. Is it? Then we have used this loop here. This loop, and what equation we have got here? This equation we have got here, 2I1 plus 2I3 minus I2 equal to 2. And you know very well, by the coincidence, this 2I3 minus I2, what we need, that already we have got here, and we have put the value here, and what we have got here, I1 we have got here 1.5 ampere here. So students, I hope so this video you have understood very well. Keep studying, keep going.